Welcome to Section 7, Applications with Transfer Learning and Deep Embeddings. In this section, we're going to take a look at Word2Vec, Representation Learning, and Embeddings. We're going to apply Word2Vec for an analogy completion task, and we're going to talk some more about embeddings by working with ImageNet and pre-trained CNNs to get those embeddings and build an image retrieval system using embeddings from pre-trained CNNs on ImageNet. So welcome to video Understanding Word2Vec, Representation Learning, and Embeddings. In this video, we're going to talk about what transfer learning is, how embeddings are important to transfer learning, and specifically we're going to talk about Word2Vec, how the Word2Vec algorithm works, how Word2Vec vectors are learned, and what type of relationships Word2Vec vectors end up capturing by the nature of the way that they're learned. So first off, transfer learning. Transfer learning is useful in scenarios where you have a small data set but a difficult problem, and there has been a similar problem solved that leverages a large data set that is drawn from a similar distribution. This means you have a task that's similar to a task that's already been sort of solved before, but your data is going to be just a little bit different. And what transfer learning lets you do is it lets you leverage everything that you can learn on the large data on a slightly different task and use that for your new task, even though you have a small amount of data. And the way you do this is you train a network on the large data, even though the task is slightly different, and you use the representations learned, the feature extraction learned from the trained network on the large data to extract features on the small data and learn a robust classifier. How embeddings come into this is embeddings are those feature representations that are often extracted from pre-trained networks. Embeddings are dense, continuous vector representations. They can either be learned in a supervised or an unsupervised manner. We'll deal with embeddings of both types in this section. And they're often useful as an unsupervised data representation scheme, similar to how we use PCA to get features of images in one of the past sections. And as a note, sometimes embeddings are also called thought vectors or X vectors or feature vectors, but we're going to stick with the term embedding from here on out. So, Word2Vec. Word2Vec is an algorithm to learn word vectors or word embeddings. And what this is for every word in our given vocabulary, we want to learn a vector representation or an embedding that encapsulates a lot of the meaning of the word. The way Word2Vec works is by using what's called negative skip sampling. And the goal of Word2Vec is that we want words that are similar to have similar vector representations. And the way we achieve that is we look at if they appear in the same context, then they should have similar vector representations. Where negative skip sampling comes in to actually accomplish this is we have our objective above, and essentially what this objective that we're trying to optimize our parameters such that our vector representation for the context and the vector representation for the word align. And the way negative skip sampling does this is by a setup of a noise classifier. So the core question that we are training it to answer is, given a word and given a context, does this come from the training data or is this completely made up? And the way you do this is you feed it a real context and a real word, and you say, yes, this is real. And the label for that is 1. To create a fake context or a fake word, you basically just draw a context along with a random word, and you train something to predict it to be fake. What this does is it's going to penalize words that appear in the wrong context and strengthen words that appear in the proper context. And words that appear in similar contexts together are going to have similar vector representations because of this. And a great property of this is that when you force certain words that are similar to be close to each other, there are a lot of latent properties among these variables, such that a lot of times there's analogies and relationships among them. So the vector between something like king and queen is similar to the vector between man and woman in a Word2Vec sense. And essentially what that difference represents is something called, would be something like the gender of the noun. Or something like verb tense is also encoded within the vector representation. So the difference between walking and walked is similar to swimming and swam. So that's encoding the tense of the term, and as well as country and capital.